Implementation of BYD's Blade battery technology by 2024, full event report. Overview. BYD, a leading electric vehicle EV manufacturer, has announced its plan to implement the innovative Blade battery technology by 2024, backed by a substantial investment of $300 million. This strategic move aims to enhance the performance and safety of electric vehicles amidst the growing demand for sustainable transportation solutions globally. Key phases of implementation. 1. Research and development (R&D). The initial phase centers on refining Blade battery technology, which employs lithium iron phosphate (LFP) chemistry. This advanced battery design significantly improves energy density and safety, notably reducing the risk of thermal runaway incidents commonly associated with traditional lithium-ion batteries. The R&D efforts will focus on enhancing the energy density of the battery to extend vehicle range, conducting rigorous safety tests to ensure reliability under various conditions, collaborating with academic institutions and research organizations to leverage the latest advancements in battery technology. 2. Pilot production. After the R&D phase, BYD plans to establish pilot production lines. This phase will involve scaling up production capacity to match anticipated market demand, ensuring that the Blade battery technology meets stringent industry standards and consumer expectations, conducting pilot tests with limited vehicle models equipped with the new battery to gather data and feedback for further improvements. 3. Mass production. BYD aims to transition to mass production by late 2023. This phase will include expanding existing manufacturing facilities or establishing new ones to accommodate increased production capacity, implementing advanced manufacturing techniques to ensure efficiency and consistency in battery production, training personnel on new production processes and quality control measures. 4. Market launch. The final phase involves introducing vehicles equipped with Blade batteries into the market, expected to begin in early 2024. The launch strategy encompasses targeting various sectors including passenger vehicles, buses, and commercial fleets, developing marketing campaigns to educate consumers about the benefits of Blade battery technology, establishing partnerships with key stakeholders including government agencies and other automotive manufacturers to promote the adoption of electric vehicles. Common key points across sources. The initiative is marked by several common themes emphasized across various reports. Investment focus. The $300 million investment signifies BYD's commitment to innovation within the EV sector and is seen as a strategic move to secure a competitive edge. Safety and efficiency enhancements. The Blade battery's design is highlighted for its enhanced safety features and improved efficiency, making it a front-runner in the EV battery market. Sustainability goals. This technology aligns with global sustainability objectives, supporting the transition towards greener energy solutions and lower carbon emissions. Differences between sources. While many sources share similar information, some discrepancies exist regarding timeline specifics. Variations in launch dates are noted, with some sources suggesting a mid-2024 rollout while others indicate a more ambitious early 2024 target. Technical details. Some reports provide in-depth technical specifications focusing on energy density improvements, while others emphasize the lifecycle and environmental benefits of the new battery technology. Timeline of events. 2022, BYD intensifies initial research and development of Blade battery technology. Late 2023, pilot production lines are expected to commence with performance testing underway. Early 2024, anticipated mass production phase followed by market launch of vehicles featuring the Blade battery. Post-2024, potential expansion of Blade battery applications across various vehicle types and markets. Conclusion. BYD's blade battery technology represents a significant leap forward in electric vehicle innovation. With a clear plan for implementation supported by substantial investment and research strategies, the anticipated rollout of this technology is expected to not only enhance the performance and safety of electric vehicles but also contribute to global sustainability efforts. As the automotive industry continues to evolve, BYD's initiatives could set new benchmarks for electric vehicle technology and battery manufacturing. Counterintuitive information in the provided content surrounding BYD's blade battery technology implementation includes 1. Investment versus timeline expectations. While BYD is committing a substantial $300 million investment into blade battery technology, there are discrepancies in the expected timeline for market launch. Some sources predict an early 2024 launch while others suggest mid-2024. This inconsistency suggests that despite significant financial backing, the company may face challenges in executing its ambitious timeline, which counters the assumption that larger investments always lead to quicker results. 2. Battery safety perceptions. The blade battery's design reportedly enhances safety by reducing the risk of thermal runaway, a common concern with lithium-ion batteries. This highlights a counterintuitive perspective where a newer technology is perceived as safer than its predecessors, potentially undermining the notion that innovation without extensive testing inherently carries more risk. 3. Environmental impact versus performance. The blade battery technology, rooted in lithium iron phosphate LFP chemistry, is presented as an eco-friendlier alternative aligning with sustainability goals. However, the improved efficiency and energy density may not be immediately evident to consumers who may associate environmentally friendly technologies with lower performance or higher costs, thereby challenging the expectation that sustainability compromises performance. For market demand versus production capacity, the transition to mass production by late 2023 is intended to meet anticipated demand for electric vehicles using this technology. However, the assumption that high demand will automatically translate to successful sales could be misleading, especially if consumers remain skeptical about new technologies or if competitors offer more established alternatives. 5. Diverse market applications. The plan to apply blade battery technology across various vehicle types, passenger vehicles, buses, and commercial fleets, could seem to reflect broad applicability. Yet this might also indicate a dilution of focus where the attempt to cater to multiple segments could lead to compromises in specialized performance for each market, countering the notion that specialization typically yields better results. 6. Consumer expectations. The emphasis on safety and energy efficiency might lead to consumer expectations that these vehicles will inherently be more expensive. However, if BYD successfully leverages economies of scale during mass production, the pricing could be competitive, which would counter the pervasive belief that advanced technologies always come with a premium price tag. 7. Long-term reliability versus initial adoption. Although BYD's blade battery technology seeks to enhance reliability over traditional batteries, early adopters may remain cautious until they can verify long-term performance and reliability claims. This hesitation underscores a counterintuitive trend where consumers might prefer proven technologies over newer innovations, even when those innovations promise better performance. These points illustrate how expectations surrounding innovation investment and consumer behavior can often contradict the realities of technology implementation in the automotive industry, specifically regarding BYD's blade battery technology. In the report regarding BYD's blade battery technology and its implementation by 2024, several key points may be overlooked by the general audience due to their technical nature and the focus on more prominent benefits like safety and energy efficiency. 1. Investment specificity and its implications. The report highlights a substantial investment of $300 million dedicated to this initiative. While most readers might focus on the end products that this investment will produce, the specifics of how this funding will be allocated across different phases, R&D, pilot production, mass production, and market launch, are often underappreciated. This level of detail is significant because it indicates BYD's strategic planning and resource allocation, which can directly affect the timeline and success of the technology rollout. Understanding the breakdown of this investment can provide insights into which areas BYD anticipates needing the most resources, revealing potential challenges they foresee in the production and integration of the Blade battery technology into their vehicles. 2. Research and development focus on safety. A notable aspect of the Blade battery technology is its use of lithium iron phosphate LFP chemistry, which enhances safety by significantly reducing the risk of thermal runaway compared to traditional lithium-ion batteries. While the report briefly mentions this advantage, the broader implications of such a safety improvement can be overlooked. The reduction of thermal runaway not only enhances vehicle safety but can also lead to lower insurance costs, greater consumer confidence in EV technology, and a positive environmental impact by reducing the likelihood of battery fires, which can have widespread consequences. This aspect is crucial in the context of increasing scrutiny on battery safety in the EV industry. 3. Pilot production as a crucial phase. The pilot production phase is often viewed merely as a precursor to mass production. However, this phase serves as a critical testing ground for the technology, allowing BYD to not only refine their manufacturing processes but also to validate the performance and reliability of the Blade battery under real-world conditions. The significance of this stage cannot be understated. A successful pilot production can lead to smoother transitions into mass production and market launch, while any issues identified here can be addressed before scaling up operations, thereby saving time and resources in the long run. 4. Market launch targeting multiple sectors. The report suggests that the market launch will target various sectors, including passenger vehicles, buses, and commercial fleets. Many might focus solely on passenger vehicles, but this multi-sector approach broadens the market potential significantly. It indicates BYD's intent to capture a larger share of the EV market and meet diverse consumer needs. Each sector may also have its own regulatory challenges and consumer expectations, which makes the ability to adapt technology across different applications a significant strategic advantage. 5. Lifecycle and environmental benefits. While the report emphasizes the safety and efficiency of the Blade battery technology, the lifecycle benefits associated with LFP batteries are often under-discussed. LFP batteries not only have a longer lifecycle, which can reduce waste and the need for frequent replacements, but they also offer environmental advantages such as less reliance on scarce materials like cobalt. The environmental implications of using LFP technology can be crucial in discussions about sustainability in the automotive sector, especially as consumers increasingly seek eco-friendly options. 6. Technological innovations beyond the battery. Lastly, the report may overlook the potential technological innovations that arise from the implementation of the Blade battery technology. As BYD invests in this new battery design, it may also lead to advancements in other areas such as battery management systems and integration with renewable energy sources. This interconnectedness of technology in the EV landscape signifies a shift towards more comprehensive energy solutions, which could have far-reaching implications for energy consumption and sustainability. In conclusion, while the report provides a comprehensive overview of BYD's Blade battery technology and its anticipated rollout, the nuances of investment implications, safety advancements, pilot production significance, multi-sector targeting, lifecycle benefits, and technological innovations represent critical dimensions that deserve closer examination. These elements not only highlight BYD's strategic foresight but also underscore the broader implications for the EV market and sustainability efforts in the automotive industry. The implementation of BYD's Blade battery technology by 2024 is a pivotal moment in the electric vehicle EV industry, driven by significant investments and a structured rollout plan. Here are 4 key points for in-depth analysis and discussion regarding this development. 1. Investment and economic implications. The $300 million investment allocated for the Blade battery initiative highlights BYD's commitment to advancing EV technology. This substantial financial commitment not only signifies confidence in the potential of blade battery technology but also sets a precedent for other companies in the EV sector to prioritize innovation. The economic implications of this investment extend beyond BYD. It could stimulate job creation, enhance manufacturing capabilities, and potentially lead to lower costs for consumers due to economies of scale in production. Furthermore, this investment might influence stock prices and attract additional investors to the EV market, fostering competition and innovation. 2. Technological advancements in battery safety and efficiency. The blade battery technology utilizes lithium iron phosphate (LFP) chemistry, which is known for its safety and efficiency. A crucial focus of this technology is the reduction of thermal runaway risks, a common issue with traditional lithium-ion batteries. This enhancement in safety can lead to broader consumer acceptance of EVs, as concerns over battery safety have been a significant barrier to adoption. In-depth examination of the technical specifications and performance metrics of blade batteries compared to existing technologies is essential to understand the potential impact on EV performance, longevity, and overall user satisfaction. 3. Phased implementation strategy. BYD's structured approach to the implementation of blade battery technology is divided into 4 key phases: research and development, pilot production, mass production, and market launch. Each phase plays a critical role in ensuring that the technology is refined, tested, and scaled appropriately before reaching consumers. Analyzing the risks and challenges associated with each phase can provide insight into how companies can effectively manage technological rollouts in the fast-paced EV industry. Understanding how BYD navigates potential obstacles such as supply chain issues or regulatory hurdles can be instructive for other firms looking to innovate in the battery space. 4. Environmental and sustainability goals. The integration of blade battery technology aligns with global sustainability objectives, emphasizing the importance of greener energy solutions as the world grapples with climate change and environmental degradation. Advancements in battery technology are crucial for reducing carbon footprints. Exploring the life cycle analysis of blade batteries, including sourcing, production, usage, and disposal, can help assess their overall environmental impact compared to traditional battery technologies. Furthermore, this discussion should include the potential for BYD's blade battery technology to contribute to the circular economy through recycling and repurposing initiatives. In summary, the implementation of BYD's blade battery technology presents significant opportunities and challenges that merit comprehensive exploration. By focusing on investment implications, technological advancements, phased rollout strategies, and sustainability goals, stakeholders can gain valuable insights into the future of electric vehicles and battery technology. 1. The Ford Model T in the assembly line, 1913 to 1927. The introduction of the Ford Model T revolutionized the automotive industry, making cars affordable for the average American. Henry Ford's implementation of the moving assembly line dramatically increased production efficiency, allowing for mass production at unprecedented speeds. This shift not only changed how cars were made but also set the standard for manufacturing across various industries. 2. The development of the Boeing 747-1968. The Boeing 747, often referred to as the jumbo jet, was a landmark in aviation history due to its size and efficiency. Its development involved significant innovations in engineering and manufacturing processes, including the use of advanced materials and systems. The 747 enabled airlines to transport more passengers at lower costs, transforming air travel and making it accessible to millions. 3. The Industrial Revolution, 18th to 19th century. The Industrial Revolution marked a major turning point in history, changing how goods were produced. Innovations such as the steam engine, mechanized textile production, and the use of iron and steel in construction led to mass production and significant economic growth. This era laid the groundwork for modern manufacturing processes and the global economy we know today. Future outlook: implementation of BYD's blade battery technology by 2024. The implementation of BYD's blade battery technology marks a pivotal moment in the evolution of electric vehicles (EVs) set against the backdrop of an increasingly competitive and environmentally conscious automotive market. With a significant investment of $300 million aimed at enhancing EV performance, BYD's strategy includes several key phases leading up to 2024 and beyond. Key phases of implementation. 1. Research and development (R&D). The initial phase is critical for the refinement of the blade battery technology, focusing on lithium iron phosphate (LFP) chemistry. This phase is anticipated to enhance energy density and improve safety features, especially regarding thermal runaway risks often associated with traditional lithium-ion batteries. By 2024, we predict that R&D efforts will lead to substantial improvements in battery longevity, safety, and environmental sustainability, paving the way for broader adoption. 2. Pilot production. Following successful R&D outcomes, BYD will move into pilot production, expected to begin in late 2023. This phase will involve the establishment of production lines that will test the feasibility of scaling operations to meet industry standards. The pilot phase will likely include collaborations with suppliers and stakeholders to ensure that production lines are optimized for efficiency and quality control. 3. Mass production. By early 2024, BYD aims to transition into mass production of the blade battery. This phase will leverage existing manufacturing capabilities and potentially expand facilities to meet anticipated demand. Analysts predict that by mid-2024, mass production could lead to an increase in the availability of vehicles equipped with the blade battery, not only in the passenger vehicle segment but also in commercial fleets and public transport solutions. For market launch, the final phase involves the market launch of vehicles utilizing blade batteries targeting various sectors from personal cars to public transportation. Anticipated for early 2024, this rollout will likely include strategic marketing campaigns to raise awareness of the benefits associated with the blade battery, particularly its safety, efficiency, and environmental impact. The market's response will be closely monitored, influencing further developments and iterations of the technology. Predictions for the future. Increased market penetration. By 2025, it is expected that BYD's blade battery technology will have captured a significant market share, particularly in regions prioritizing sustainable transport solutions. As governments worldwide implement stricter emission regulations, the demand for efficient and safe EV batteries will grow, facilitating BYD's expansion into new markets. Technological advancements. Continuous technological improvements will enhance the performance of blade batteries, focusing on increasing energy density and reducing charging times. By 2026, we predict advancements in battery recycling technologies that could further bolster sustainability, making BYD a leader in eco-friendly automotive solutions. Collaborative partnerships. As the EV market matures, strategic partnerships with other automotive manufacturers, tech companies, and battery suppliers will become essential. By 2027, BYD may establish collaborations that allow for shared R&D costs and innovations, accelerating the development of next-generation battery technologies. Global expansion. Following a successful rollout in its home market of China, BYD is likely to expand its blade battery technology to international markets. By 2028, we could see the introduction of blade batteries in Europe and North America, supported by BYD's growing production capabilities and distribution networks. Consumer adoption. By 2029, consumer adoption rates for vehicles equipped with blade batteries may significantly increase, driven by heightened awareness of climate change and the benefits of EVs. This trend will be supported by government incentives and a growing infrastructure of charging stations, making EVs a more viable option for the average consumer. Market competition. The successful implementation of blade battery technology will likely spur competition among other manufacturers to develop similar or superior battery technologies. By 2030, we can expect a broader range of battery options in the EV market, leading to innovations that could further enhance vehicle performance and safety. In conclusion, BYD's blade battery technology is poised to transform the electric vehicle landscape by 2024 and beyond. Through careful planning and execution across its key phases alongside predictions of increased market penetration, technological advancements, and global expansion, BYD is set to play a crucial role in driving the transition towards sustainable transportation solutions.